Have you ever watched a movie like The Matrix and wondered, could we actually build that? I'm not talking about the whole humans as batteries thing, but the idea itself, a perfect, data-driven simulation of our world. Well, you might be surprised to hear that we're already doing it. It's called a digital twin, and believe me, it's about to change how we see our cities forever.
Okay, so let's just take this in for a second. What you're looking at here isn't a shot from a video game or a special effect from a movie. This is a digital twin. Think of it as a living, breathing virtual copy of a real city, built with unbelievable precision and just humming with data about, well, everything, from traffic patterns to air quality. So to put a formal definition on it, a digital twin is a virtual replica of a city's built and natural environment, and it's layered with real-time and historical data. This lets us simulate, analyze, and plan how the city actually works. It's so much more than a map. It's like a sandbox where planners, engineers, and really anyone can test out big ideas, see what might happen, and understand their city in a totally new way.
I know, this all sounds like it's straight out of science fiction, but it is very, very real. So the big question, the one we're all thinking, is how on earth do you even start building a digital copy of an entire city? Well, that's exactly what we're going to break down in this explainer. To get our heads around building this massive virtual world, we actually have to start small, really small. We're going to zero in on a single, everyday object that we all know, just a simple roof.
Let's ask a really practical question. For this one specific roof, how much solar energy could it actually generate? Believe it or not, figuring out how to answer this one simple question with perfect accuracy is the key to unlocking the whole process.
You see, the old way of doing this was pretty basic. You'd look at a flat 2D map and just measure the building's outline. But that's just a rough guess, right? A roof isn't flat. It has slopes, different angles, it faces different directions. The new method, however, calculates the true 3D surface area, capturing every single one of those geometric details.
And that right there is the key. That true 3D geometry is everything. It's what lets us precisely calculate not just how many solar panels you could fit, but also things like rainwater runoff or even a building's shadow. That level of precision, it really matters, and it all starts with getting the shape exactly right. So the next logical question is, how do they get that perfect 3D geometry? I mean, they're not out there hand-drawing millions of buildings. Nope, it's done through this brilliant process that turns plain old photographs into incredibly complex 3D models. The technology that makes this all possible is a patented process called photogrammetry. You can think of it as a four-step recipe. First, you capture what are called stereo images from an airplane or a drone. Then, some really powerful software creates a point cloud, which is literally a cloud of millions of tiny, precise data points. Next, those dots get connected to form polygons, creating a sort of digital wireframe. And finally, the software analyzes that geometry to create the finished 3D model. Now that first step, stereo imaging, is the magic ingredient, and it works just like our own two eyes, right? Each of your eyes sees an object from a slightly different angle, and your brain mashes those two views together to give you depth perception. It's the exact same idea here. A plane flies in these carefully planned overlapping paths, snapping pictures of the same spot from different angles. That's how it creates that 3D view. And get this, according to the actual patent for this technology, there's a magic number. For the whole system to work, the photos have to have at least a 30% overlap. That specific overlap is what gives the software enough information to accurately calculate all the depths and shapes on the ground.
Okay, so we now get how to create a perfect 3D model of one single roof using a few photos. But how in the world do you scale that up to model an entire city? This is where things get really impressive.
Well, to chew through millions of photos covering hundreds of square miles, you need an industrial-scale software pipeline. It's basically a digital assembly line. The photo data gets ingested in one program, the raw 3D model is born in another, it gets cleaned up and refined in a third, and in the final step, those photorealistic textures are painted on. Each part of the process is built to handle just a massive amount of data. And what's cool is that this digital assembly line can produce different kinds of products. A city might only need something simple, like basic building footprints, or maybe some simple gray 3D models. But it can also go all the way up to those beautiful photorealistic textured models. And at the very top of the pyramid, you get the whole shebang, the fully loaded, data-rich, smart digital twin.
And that brings us to the final and, frankly, the most exciting part. We've built the perfect 3D model. Now, we make it smart.
This is where all that raw data comes to life and turns a pretty picture into an unbelievably powerful tool.
So we're back where we started, looking at this amazing image. But now, it makes a lot more sense, right? We actually understand how that physical layer, that 3D core, was painstakingly built from photos. But you have to remember that beautiful model is just the foundation. The real intelligence, the real power, comes from all the different layers of data we stack on top of it.
And these are the layers of what you could call urban intelligence. On top of our 3D core, we can add a regulatory layer with all the zoning rules. We can add an environmental layer with data on things like floodplains. We can add a mobility layer with real-time traffic feeds. We can even add a financial layer with property values for every single building. All of a sudden, the city's entire operating system becomes visible and searchable all in one place.
So, what can you do when you have all that data fused together? You can talk to it. No, seriously, all of this data powers what's being called a city assistant AI. It's basically an expert on the city that you can ask questions to, just like you would a person.
And this quote from the source material just illustrates the endgame perfectly. It's a conversational interface that allows users to ask natural language questions about their city and get answers instantly in context. Think about that. You could ask, "Show me all commercial buildings over 5 stories tall that are near a subway stop," and boom, the AI would highlight them on the 3D map instantly.
So that really brings us to the final thought. We've gone on this journey from a single roof to a photorealistic model, all the way to a simulated city that you can actually talk to. It's incredible. So I'll leave you with this question. If you had access to this for your city, what would be the very first thing you'd ask its digital twin?